Assalamu alaikum. This is Dr. Ahmad Al Faris. Today we're going to answer paper 2, the multiple choice question, February, March 2022. In this paper, we have 40 multiple choice questions. And let's do the first one. A student investigates the pendulum. Okay, a student investigates a pendulum. He measures the time for a pendulum for 20 complete oscillations. The number of oscillations here, measure for 20 complete oscillations to find the period for each one. So he needs to divide it, the total time that he found, divided by what? The number of oscillations. He repeats the experiment 3 more times. So he did it once and he repeated another 3 more times. So he did it 4 times. 1, 2, 3, 4. The readings are shown: first experiment, second, third, fourth, and the readings, as you can see, they are close to each other. They are 17.6, 19.8, 17.6, 18.6. Okay, so there is no anomaly here. What is the average period of the pendulum? Now we need to find the period here, and the period is the time divided by what? The number of what? Oscillations. But since here, okay, we have 4 experiments, we need to find the mean of the time to be more accurate. So the time mean here, okay, the average time, it's equal to the addition of all times divided by their numbers. And the addition here is 17.6 plus 19.8 plus 17.6 plus 18.6 divided by 4, and the mean time, it will be how much? It will be 18.4 seconds. Now this is the mean. Okay, we substituted this value here. Okay, 18.4 divided by 20 complete oscillations to find how much is the time for one complete oscillation, and the answer will be 0.92 seconds, which is answer B, due 2 significant figures or 2 decimal places. Okay, this is the first question. Second question, what do we have here? A tennis ball falls from upstairs window of a house. Now when they said a tennis ball, that means it has a little bit high density. It's not that huge density, so it may be affected by air resistance, maybe not. But since they are saying upstairs, that means 1 floor, so it will not reach that high speed to reach to be affected by air resistance. So maybe the air resistance is negligible, because we know that whenever the speed increases, the air resistance increases. And the most important thing that affects the air resistance is the density of the object. And since tennis ball has a little bit high density, not as an inflated balloon or something like plastic ball, okay, so that means, okay, it has a high density, so maybe it will not be affected by air resistance. And that, when we said that, okay, it's not air resistance is ignored, that means the gravity acceleration is the acceleration of this object, which is equal to 10 meters per second square, and remains the same. What can be said about the acceleration of the ball? It depends on the density of the ball. Of course, it depends on the density of the ball. As we say that if there's other factors, if they mention something about resultant force here, and they give us how much is the, because we know that the resultant force is equal mass multiplied by acceleration, so we have to know how much the resultant force, depending on the density and the air resistance, to find how much is the acceleration. So this is not the accepted answer now, because we know that there is air resistance in the north. So the only force that acts on it, the resultant force, it's only its weight acts downwards. Okay, there's no air resistance acting upwards. So that means the weight, which is equal mass times what? Acceleration. The weight, which we know that equal mg, is equal to the mass multiplied by the acceleration. Mass with mass cancel out each other. Okay, so that means the acceleration is equal to the gravity acceleration in this situation, in this example. It depends on the mass? Never. It doesn't depend on the mass here. Okay, it increases as the ball, okay, falls. No, actually, if there is air resistance, it will decrease, not increase, because as the speed increases, air resistance increases. But here they say that the air resistance is not ignored, negligible. There is no air resistance. There is no other force in the opposite direction of the motion that acts downwards. Okay, it stays the same. We said that it stays the same as the object falls. Okay, so the answer is what? D. Next, what do we have here? We said that here we have a question that said a car joined a road at a speed of 14 meters per second. This is you, 14 meter per second, and accelerate at 4 meters per second square for how long? For 5 seconds. So a road, okay, enter a certain car, sorry, enter a certain road with a certain speed, and initial speed u equal 14 meters per second, and there is acceleration. He speeds up, he pushes the gasoline, the brake, to increase the thrust force, to make a resultant force causes this acceleration, 4 meters per second square, for how long? 5 seconds. Find out the final speed after the 5 seconds. Now we know that acceleration, now the final speed is the thing that we need to find out. Acceleration equals v minus u divided by t, or you can rearrange the formula to make v as the subject of the formula. Now the acceleration here, we have it, which is 4 meters per second, equal v that we want to find it out, minus u, which is 14, divided by the time, which is 5. Doing cross multiplication, find v as a subject of the formula, and v, it will be how much? It will be 34. So v equal 4 times 5, which is 20. Move the 14 to the other side, plus 14. So the answer, it will be 34 meters per second. So the answer is D. Okay. Next question, question number 4 here. What do we have? The gravitational field strength is 8.8 Newton per kilogram on Venus and 3.8 Newton per kilogram on Mars. Okay, so we have two different gravitational field strength on two different planets. Okay, an object has a weight of what? 42 Newton on Venus. On this planet, Venus, okay, we have an object that weight 42 Newton. What are the mass and the weight of the object on Mars? Now, the mass doesn't change for any object. The mass remains constant. Okay, on Venus, on Mars, on Earth, anywhere, the mass doesn't change unless we add an extra mass or it, or we subtract a mass from it. We take off a certain mass of it, or we join other objects to each other, the mass increases, or we split object from each other, the mass will what? Decrease. So the mass remains constant here and doesn't change. So we have to find the mass here. So first of all, okay, we know that they tell us that, okay, the weight on Venus is different than the weight on what? On Mars, okay? Two different planets, two different gravitational field strength, okay? But we know that the weight everywhere, the formula for it is equal to m multiplied by g, the gravity acceleration on the planet. Okay, so I'm going to use this equation twice. Once on Venus, so weight on Venus, okay, equal the mass, which is Dawson's change is constant, multiplied by the gravitational acceleration or gravitational field strength on Venus. So it will be 42. This is the weight on Venus, okay, and this is the gravitational field strength on Venus, and this is the gravitational field strength on what? On Mars. Equal the mass multiplied by the gravitational field strength on Venus, which is 8.8. So divide by 8.8, divide by 8.8, the mass, it will be 4.8 kilograms. And that make the answer can be A or B. Now, this is the first step here. Next, I'll use the same formula again to find how much is the weight on Mars. And the weight on Mars is equal to the mass of the object that doesn't change, remains 4.8, multiplied by the gravity acceleration on Mars. And the gravity acceleration on Mars is 3.8, multiplied by the mass, we just find it out, which is 4.8. And by doing our calculations, we will get that the answer, it will be how much? 18.24 in Newton. So I put it as two decimal significant figures, which is 18. So the answer will be what? Will be A. 18 in Newton. Next, what do we have here? A student carried out an experiment to find the density of a rock. Now, which two measurements does the student need to measure to determine the density of the rock? Now we know that density equal mass divided by volume. That's a standard here. But here we have two masses And here we have two volumes. So what do we need? We need to find the difference between the masses, okay, and the difference between the volumes to find the density of the rock before and after, because the mass over the density in the first situation is the density of what? Of the liquid. The mass divided by volume of the liquid, it's the density of the liquid, okay? Maybe with a measuring cylinder, maybe not. So we have to check the zero or find the mass of this measuring cylinder. Okay, and here also, this is the average speed. If I find the total mass divided by the total volume, this is the average speed for the liquid with the rock together. So what do we need here? What are the two measurements that does the student need to determine the density of the rock? The increase of the mass, okay, the increase of the mass is correct answer. The final mass is not accepted, okay, because the final mass for the liquid with the rock, maybe with the measuring cylinder, okay, and the increase in what? In volume, okay, as we said, how much the volume does increase from here, from this volume V1 to this volume V2. So that makes the answer is what? A for question number 5. In question number 6 here, what do we have? A car has a mass of 1,500 kilogram, 1,500 kilogram. A constant resultant force acting on the car, and the car accelerates from 15 meters per second, this is U, to 20 meters per second, this is V, and how long? In 4 seconds. What is the magnitude of the resultant force acting on the car? Now we know that the resultant force, as we said before, is equal to the mass multiplied by what? By the acceleration. So the mass, which is 1,500, 1,500, multiplied by what? The acceleration. So we need to find how much is the acceleration. So we know that the acceleration is the change in velocity, v minus u, divided by t, okay? So the final velocity here, which is 20, minus the initial velocity, which is 15. How do we know? Because they say 2. This is initial, this is final, okay? So we subtract the volume, this is the change, the velocities, this is the change in velocity, this is the change in the speed, divided by the time, which is how long? 4 seconds. So here it will be 5 over 4, which is 1.25, okay? And then what do we have here? 1.25. I will use this value, 1.25 meters per second square, and I will substitute it here instead of what? Of the acceleration multiplied by 1.25, and by using the calculator, my answer will be 1,875 watt Newton. So if we round up this answer into two significant figures, it will be what? 1,900, 1,900 Newton. This is the answer. Okay, good. Next. Question number 7. What do we have here? In this question, they say that a metal wire is loaded up to the limit of proportionality, okay? Which statement is correct? Before that, what do we mean by limit of proportionality? In Hooke's law, we use the limit of proportionality to tell us the relationship between the force and the extension for any spring is directly proportional, and the same thing for the wire. It's supposed to be a straight line, then it starts at a certain point, straight line, that means they are directly proportional, then it starts to what? To get to be curved, not a straight line, since it's not linear, so there is no directly proportional relationship between the force and the extension or the change in length. Some books they put it x, e, or delta L, it doesn't matter, it's extension in what? In meter, okay? Which statement is correct? Hooke's law is not obeyed when the load increases from 0 to this point. Of course, it's obeyed from 0, 0 to this point, which is the limit of proportionality, okay? LP, okay? The limit of proportionality, it is obeyed. It's not obeyed, that's not correct. Then what they ask here, part B, when the load is increased beyond the limit of proportionality, the diameter will be increased. Actually, Actually, any wire, when you extend it like a chewing gum, okay, if you hold it, okay, sorry for this example, if you hold it and okay, and or rubber band, okay, and you stretch it, you'll find that the diameter of it becomes less, it becomes smaller. So that's not correct, okay. C, when the load is removed, the wire return back to original length. Yes, when they say that it's directly proportional, that this is the loading until this point and this is the unloading, so it will not be deformed. So the answer so far is C. It's undeformed. So that means the wire or the spring, okay, until this point, it can return back to original dimension, to original length. D. Up to the limit of proportionality, there is no change in the shape of the wire. There is extension. There is extension. It cannot be no change in the shape. The length will be more. So there's change in what? In shape. Okay. Question number 8. In question number 8, the diagram shows a uniform meter rule, MN. So they said uniform. When they said a uniform, that means the center of its mass is exactly at the center of its shape. MN, pivoted at the midpoint. The midpoint, so that means this is the midpoint where the weight of the meter rule is acting downwards, and there is also normal reaction force from the support acting where upwards. What do they ask here? Two weights, W1 and W2, W1 and W2 are hang from either sides of the pivot. The rule, okay, remains balanced, okay? That means it's equilibrium. And when we say that it's equilibrium, or balance, what that means? That means the resultant force equals 0 on the object, and also the resultant moment on the object, also on the meter rule, it remains 0. That means moment here, the forces up and the forces down are equal to 0, and here the moment clockwise and the moment anti-clockwise are equal to 0. Which row is correct? Direction of the resultant moment about the pivot, there is no resultant direction. There is no moment actually. Okay, so it's 0, 0. And also, they said here, the direction of the resultant force on the meter rule, we said that is 0. There is no direction. There is no upward and downward because forces up is equal to cancel the forces downwards. So it's 0, 0 because they said the word balance. So that means the answer is what? Is D. Question number 9. Which physical quantities is vector? Vector quantities are the quantities that have magnitude with direction. Since we have any quantity that has direction, that means it's a vector quantity. Mass, for example, my mass is 90 kilogram. That means I will not mention it downwards. It's mass, not weight. Density, it's mass per volume. So also scalar and scalar. There is no direction for it. The opposite of vector is a scalar quantity. So both of them, they don't have direction. Temperature also doesn't have direction. It's a value that gives us how hot or cold is the object. So 3 of these values, A, B, C, they are quantities that are scalar. They don't have direction. Velocity, it's a speed with direction. So when we are saying speed, it is scalar, but when we say this speed, velocity is a speed with direction. So that means it's what? It's a vector quantity. Okay. Question number 9. That's it. Question number 10. The resultant force of 500 Newton act for 10 seconds on a car of mass 1,000 kilogram. This causes the velocity of the car to what? Double. What is the final velocity of the car? The resultant force of how much? 500 Newton for 10 seconds on a car of mass 1,000 kilogram. This caused the velocity of the car to double. So that means there was initial velocity and increased to V, which V equal to U twice, double the initial velocity, double. What is the final velocity of the car? They ask about V. So I need to find U and I'll double it. Now we have 2 ways to answer this question. We can use momentum to find out the answer of this question, or we can use the resultant force and acceleration to answer this question. So for example, if I said acceleration equals V minus u divided by t, sorry. So in this equation, okay, I can rearrange it. Instead of v, I'll write 2u, so it will be here 2u minus u divided by t. This is equal what? The acceleration. So 2u minus u, okay, it's u over what? Over t. So from x, that means acceleration equal u, initial speed divided by time. This is the first step. Second step, what I'm going to do here, I'm going to use the what? The formula resultant force equal ma, okay, to indicate resultant force equal ma, to indicate how much is what the acceleration. Then I will substitute it here. So the resultant force of 500 Newton, okay, is equal what? The mass, which is 1,000 kilogram, okay, multiplied by the acceleration, and the time they give it to us, it's 10 seconds. So I'll multiply it by the acceleration, which is u divided by what? By the time, which is 10. So 0 with 0 cancel out each other, then divide by 100, divide by 100 to get how much is u. So u, it will be how much? U, it will be what? 5. Okay, u, it will be what? 5 meters per second. So if I use this statement that the velocity is doubled here, that means the final speed, okay, v is equal what? 2u. That means 2 multiplied by 5, and the answer, it will be what? 10 meters per second. Okay, this is the easiest way to answer this question. Okay, we have a lot of unknown values that we have to put together. Okay, so the acceleration equal v minus u over t. The v, it's double u, that means 2u minus u, so it will be u over t, and t, it's 10 seconds. So that means the acceleration here equal u divided by 10. Okay, substituted in the equation of resultant force equal mass multiplied by acceleration, and what here? So the resultant force, which is 500, equal the mass, which is 1,000, multiplied by the acceleration, which is u divided by 10. This 0 cancel with this 0. Divide by 100, divide by 100, that means u equal 5 meters per second. Now they ask about the final velocity, how much it will be, v equal question mark. So we find that the initial velocity is 5 meters per second. They say that the final velocity is what? Is doubled. That's because the velocity to be doubled after 10 seconds. Okay, so the answer 2 multiplied by 5, which is 10 meters per second. Next question. A child pushes a toy car along a horizontal surface and then releases it. As the car slows down, what is the main energy transfer? Now, the main energy transfer, we push it. That means there was a force from inside the person, the child, okay, as chemical energy, and this chemical energy becomes what? Becomes kinetic energy in the toy, okay? But they ask, as the car, the toy car, slows down, not from the child, not from beginning. So there was kinetic energy here. So the pushing has chemical energy, okay? And he make it what? Move. So now it becomes kinetic energy and it slows down. Eventually it will stop. So that means it becomes what? Thermal energy due to air resistance or friction or any other force, any other forces. So during its slowing down, what is the main energy transfer? It's from kinetic to what? To thermal energy. Question 12. At time equals 0, a cannonball is stationary inside a cannon. Stationary, that means u equals 0. The cannonball is then fired into fired from the cannon. At time equal t, the cannonball moves forward and the cannon moves backward. So the cannonball, it's pushed to move forward and the cannon itself is moved backward. Like when you see a person has a gun and he shoots the bullet moves forward and his hand moves what? Backwards. Okay? What happens to the total kinetic energy and the total momentum of the cannonball. Okay, and when then between 0 to t, 0 time equals 0 to t equal t second. Now, since they said that it is fired, okay, that means there was chemical energy that we use it to increase their speeds. Both of them, there was stationary. There was no kinetic energy. The total or the sum of the kinetic energy before initial equal what? 0. After that, it changes. So it becomes what? Increase, because now both particles, they move, one move forward, the cannonball moves forward, and the cannon itself moves backwards. Okay. The total momentum of this, okay, because we know that momentum is conserved, the total momentum before and the total momentum after any explosion or any pushing or collision, okay, it remains the same. So that means the answer is A. Question 13. What do we have here? In question 13, a small hydroelectric power scheme, okay, 800 kilogram, this is the mass of water, drops from a vertical height of 2.2 meters for every second. This is the time. The electrical output energy is 10.4 kilowatt, 10.6 kilowatt, that means times 10.3 watt. This is the output power output. Okay, they give it to us in power, in watt. Okay, what is the efficiency? Now we have to know that efficiency is there's a formula that efficiency equal power output divided by power input, and the power output is electrical. Why the power input is the what? Gravitational potential energy from the water that falls. Okay, and we have to know that this energy, gravitational potential energy, is equal to mgh, which is the mass 800 kilogram multiplied by g, which is 10, multiplied by h, which is 2.2. And all of this happens every 1 second. So if I'm talking about the power, then it's mgh 800 times 10 times 2.2 divided by the time, which is what? 1 second. Every second this is happening. Okay, that means the efficiency, which is output over input, I have to find how much is the energy input. And the energy input, it's 10,600. This is the energy output. Okay, I'm sorry. By using calculator, it will be 17,600. So 17,600 is the efficiency. Okay, this one is equal to power output, which is the electricity, 10.6 kilowatt, divided by 17.6 kilowatt. And by using the calculator, the answer will be how much? The answer will be approximately 60.23. Okay, so the answer is what? 60% multiplied by 100%, of course. Good. Next. An object is at rest on a horizontal surface. Which equation is used to calculate the pressure that the object exerted? Okay, pressure, we know that is equal to force divided by area. And the force usually, okay, is the weight of the object. It's not the mass, it's the weight of the object. This is the force in this situation. So mass of the object, no. Weight of the object, yes. Divided by what? The contact area. So not multiplied. So the answer is what? Is B for question 13.